Hello, welcome to the second last section of the course, Higher Level Abstractions. In this section, we'll be first extracting code into methods, then we'll be using transformations and simplifying these code with transformations and creating transformer class. Moving on, we'll look at file-based caching, and finally we'll be using transformation onto track execution time and debug observables. Now we move on to the first video of this section that deals with extracting code into methods. In this video, we're going to extract code into more maintainable methods. Extracting code into separate methods is a very simple yet super effective technique to clarify the purpose of certain elements and to make it easier to understand what's going on. To see how effective the method extraction technique can be, we'll first try out a simple example on .filter in the Twitter stream filtering code. So, in the main activity file, we've added this code. The .filter block here is responsible for the removal of tweets that do not contain the keywords. Let's make this explicit by extracting a method. For this, we've replaced this filter method with this block of code. Also, the extracted method contains this code. In this code block, we can see that it returns a lambda that conforms to the type of predicate stock update, which is required for the .filter method. Extracting a method made .filter more descriptive, and now we do not need to analyze the details of the implementation to understand what is happening. Basically, we replace the lower detail implementation with a higher level concept. This can be done by following a few simple steps. First, we need to select the code that needs to be extracted. This is the block we need to extract. Then right-click on the code and select the option Refactor. Then select Extract, and then click on Method. A dialog box opens up, and here enter a name for a new method. Here we name it as contains any of keywords, and then click on OK. A very similar extraction method approach can be applied to consumer actions, as shown here. Here the error handling code can be extracted with this show toast error notification method. Also, the method itself contains this block of code. This way, the actions become more descriptive and take less space in the flow itself. It's not necessary to return a new lambda every time with the method calls. In lots of cases, we can use method references directly. Instead, we could have as well created a method as shown here. Then we can replace the .filter with .doOnError as shown here. There is very little difference between the two approaches, and it boils down to the personal preference. Usually, calling method gives more flexibility to do additional stuff inside the show toast error notification call or the so-called lambda factory. However, the approach that uses the method reference avoids needlessly creating new lambdas every time. We'll now be learning to extract .FlatMap. .FlatMap parts of the flow can become really complicated. Often they contain nested calls and calls to multiple .map, observable.just, and other functions. This makes the .FlatMap function interfaces a prime candidate for simplification by method extraction. We'll consider the tweet retrieval part. We'll replace this chunk of code with this code. This block has such a flow where this FlatMap maybe can be extracted to make the bigger tweet retrieval flow simpler. We'll do that by introducing skip tweets that do not contain keywords method. So the .FlatMap maybe call changes as shown here. This is the body of such a method. Again, this can be done very easily using the IDE refactoring functionality. Until now, we've used method extraction technique to simplify consumers, .FlatMap, and other similar calls. However, there is a slight difference when we're creating a method to create something that can be used completely independently in multiple places, as opposed to a method that was just used to extract a tightly coupled piece of code. Such an approach is called a factory method pattern. It's basically a method that hides the complexity of object creation. In our code, we have a few candidates for that, and all of them create complex observables that produce stock update objects. First one is financial stock quote retrieval from the Yahoo API. Next is tweet monitoring, and the final one is backup flow that reads items from a local database. All of these observables have relatively complex creation code, and they can be definitely reused in other places independently. We'll now learn about financial stock quote observable. We can start by extracting a factory method for the observable that's responsible for the retrieval of financial stock quotes from Yahoo API using this block of code. This code can be extracted into create a financial stock update observable method. This is the whole block of code. It's a simple change, but the observable.merge block looks like this. The extracted factory method can even be moved to some other class, but there is no need for that yet. And there is a clear destination class for that. So we'll leave it in the main activity class for now. The identical approach should be applied to the observables that's responsible for the retrieval of the tweets for the keywords that we're monitoring. This is the code used for retrieval of tweets. This block can be named as create tweet stock update observable. It will have a body like this. Now, the observable.merge block has become super simple. It's really obvious that we're creating an observable that merges data from two observables. One of them is supplying financial stock updates, and the other produces data from tweets. Currently, in our main observable flow, there is a big chunk of code that's responsible for the retrieval of financial stock updates and tweets in case there was an exception in the upstream. So here, we'll modify this code by adding this code. As you remember, this is used to retrieve elements from the local database when there is no internet connectivity. This big piece of code is quite distracting and takes attention of the purpose it's supposed to complete in the flow. So it should be extracted into something more descriptive, such as this, .onException resume next method. Obviously, the create local DB stock update retrieval observable method contains the same functionality as before. Since this creates a completely new and independent observable, it can be reused in multiple other places. It makes sense to move it to the store.io factory class from main activity where it was just extracted. This factory method will need a few slight modifications, as it can be seen here. Since store.io factory.get requires the context from Android, we have to pass it as an argument. Here, the relevant part in main activity will change to this. By extracting a simple factory method, we've basically simplified our existing flow by more than 10 lines, and we gave a name to properly describe what's happening. Now the other developers will have a much easier time wrapping their heads around to what the code does. After all the modifications we've made, the flow has become much more easy to understand. It still has some unwieldy do on next and observe on calls, but as we'll see in the next section, some of them can be taken care of using observable transformations. This brings us to the end of this video. Here we extracted code into methods,